In essence, Quantum Random Access Memory, or QRAM, serves as the main memory for quantum computers. It plays a pivotal role in efficiently storing and accessing data within quantum computing systems. To grasp the concept of classical RAM, let's consider the analogy of a photo of a cat. When you store this photo on a classical computer, it undergoes conversion into binary code, a series of zeros and ones that represent the data in a format understandable by the computer. Classical RAM then stores this data incrementally, enabling the computer to retrieve and reconstruct the entire image as needed. Classical RAM can store classical data only, but this invented QRAM stores both classical data and quantum data. Unlike classical RAM, which breaks down the image into multiple parts and stores them separately, QRAM can store all the data pertaining to the photo of the cat in a single location. This consolidation of data not only saves space, but also enhances storage efficiency exponentially. Furthermore, QRAM offers the remarkable capability to read from and write to all memory cells within its memory simultaneously. To illustrate this concept, let's visualize a set of photos being converted into qubits and simultaneously stored in QRAM. This capability is truly incredible. To implement 16 GB of classical RAM, a total of 137,438,353,472 bits are required. However, in contrast, to achieve the same storage capacity of 16 GB using QRAM, only 43 qubits are needed. Classical RAM's sequential data access from all memory cells makes it slower for large datasets, akin to our turtle's steady plotting pace. Classical RAM operates with a time complexity of O to the power n for data retrieval from all memory cells, indicating that the time required increases exponentially when reading the data from all memory cells. On the other hand, QRAM has the ability to write to or read data from all memory cells simultaneously, giving it a time complexity of O1. This constant cost of access is similar to our rocket's rapid journey, where data can be accessed from all memory cells instantaneously. In other words, you can think of classical RAM as a regular library where you check out books one by one. If you want to gather all the information contained in these books using classical RAM, you'll need to read each book individually in order to find all the desired information within them. It's a sequential process, similar to browsing through each book on the shelf to access the knowledge it holds. With QRAM, you can gather all the information contained in these books simultaneously. QRAM reads all these books at once, providing you with instant access to the information you need. The amazing capabilities of this invented QRAM make quantum computers highly efficient in information processing and will revolutionize dramatically the field of artificial intelligence.